to the data engineering. My name is Odessa. I'll be your host, and Eliza here will be your co-host. Before you proceed, I request you to silence your phones and refrain from using flash photography during this session. This session will last 45 minutes. It will be recorded and available online in a few minutes. So our speaker will be open to taking questions. We encourage you to raise your hand for any questions, and we'll facilitate a Q&A session to engage you with the speaker directly. Aasman is a PhD psychologist and expert in cognitive science, as well as CEO of Franz, an early innovator of artificial intelligence and provider of knowledge graph solutions. As both a scientist and CEO, Dr. Aasman continues to break ground in the areas of artificial intelligence and knowledge as he works hand in hand with numerous Fortune 500 organizations as well as government entities worldwide. Hans will be talking about data fabrics and knowledge graphs for the AI enterprise. So without prolonging the anticipation, I'm pleased to pass the spotlight to our speaker. We're truly grateful for your presence here. Hans, the stage is all yours.
So before I dive in, here doesn't have the data fabrics. They weren't active on the graph database. One? Oh my God. Okay. Right. My next question would have been who works with the semantic graph? Would you work with semantic graph? Yep.
Yeah, a little bit.
Okay, so I'll probably take it slower. All right. So, and most of you are in academia, business. Who's in academia? No one. Business. So, according to Gartner, but Gartner is probably wrong here. By 2025, right, 80% of all data analytics and graphs will be used almost everywhere. And finding relationships between elements is super important in your data. And when you look at the questions that Gartner get, about 50% of them involve AI in the user knowledge graphs, right? So maybe that everyone raised his hand when they were looking at the knowledge graph. And the other thing is, Gartner gets a lot of questions about the use of graph databases and knowledge graphs, and how you should combine them with LLMs. Everyone is here using LLMs, of course. I'm guessing. Okay, so you know, knowledge graph, LLMs are not entirely trusted. And what people have identified is it's actually very handy to combine regular graph database technology. LLM, so that the graph can be the trusted sort of data. LLM can help fill it in your database query. So I'm going to talk a little bit about graphs and knowledge graphs and why people actually use graphs and knowledge graphs. Then I'll get a little bit into data fabrics, and then I'll give you talking about the abstract part of that really first. I'll go much deeper into an example of a knowledge graph. And once I've done that, I'll talk about all the ways that we use LLM in our company. Use LLMs to fill the knowledge graph, query the knowledge graph, and even how to read out hallucinations that you might get when you're using it. Right. Let's go in. So this is a picture. So that's probably know, right? So any relational database, Excel spreadsheets has rows and columns. You don't have that in a graph database. You have nodes, links, data, entities, and the relationship between entities, and you get a graph. You get a graph database like ours, a Lego graph, or the other ones, the Tiger graph, or the J graph, that, right? So you have these graph databases, and then you build applications on top. Your graph. Usually they're a mix of machine learning, structured text, and then everything you do with graph, rule-based systems. If you're a meaningful application, then you start using these things. Knowledge graphs. Step up. foundational layer on top of graphs. Now, so we built knowledge graphs for our customers. We do it in healthcare, in aviation, for the government, publishing, we do it in call centers. And when I talk about it, people always say, because I usually talk about one task, and say, yeah, I can do that in Elasticsearch, I can do this in my relational database, I can do this in Mongo, I can do this in timescale DB. Why would we use a graph database? Well, I always ask these people that. So if you have a network of highly interrelated objects, how do you do that in Mongo? There are objects in there, graph search, it won't work, right? Or Elasticsearch, or relational databases. Yeah, you can get plugins, and SQL is getting more and more graphy, if you think about it. But when you look at it, you have a lot of objects that need to be on the graph database just much better. So that's why Facebook, LinkedIn, IREST, NSA, FBI, Google all have their knowledge graphs where they collect information about you and your relationship with everyone else and all the things you use. And so they built this whole thing about your preferences, likes, and also get to know you better, right? For positive purposes. So that's what people use. Well, so we have highly connected graphs. The other thing is, if you have very complex data, say you want to take biological pathways, that would be the human body, then the causal chains of how certain medications work in your body, or complex medical taxonomies, how are you going to ever put it in a relational database, right? You wouldn't even think about it, but graph database technology is especially built for very, very complex data. And then the other thing is, it's very easy to have a big company where you have at least 10,000 databases. Sounds crazy, but if you count all the databases that are used for more than 10 people, I've seen even much higher numbers. And all these things are in silos, so you want to connect them. In any case, there's value if you can integrate data. There's people that say that 75% all IT money actually will go into data integration. This is an amazing, staggering number. But how do you know where your data is, what the data means in the particular point, right? And how this data element there might be connected to the data element there. And what where it is and how it relates to core objects in your company, the things you really care about, right? And that's another place where knowledge graphs really, really helpful. Now, again, it's not present that uses graphs, and it's not, but there's two kinds of graph databases. There's what they call labeled property graphs, where as a programmer you can make up the name of the nodes you want to connect to other nodes, and you can make that the name of the edge from one node to the other. But you don't use any standards. You can just connect anything you want in a way that the programmer wants to. If you live in our community of semantic graph databases and semantic knowledge graphs, we actually use standards by the W3C. It's called standards like RDF, RDFS, OWL. Anyone ever hear of these standards? Okay, so I always tell people, if you have a problem and you want to solve it, you need to solve it with a graph database. If you don't care if your graph is going to be interoperable with all the other graphs, graph applications in the company, use any database you want. But if you find it really important that the new graph application that you built can connect to everything else, then you better use what we call a semantic graph database. And I'll explain in a second what that means. Actually, let me explain it now. So, semantic technology is like one of the biggest parts of W3C. But if you really get to it, there's only two things that are really important. One of them is that you make sure that the same thing gets the same name. Right? So every entity gets a unique URI. Right? And these URIs or the namings are defined in ontologies that describe objects in the company and taxonomies that describe every word that's important in the company. So that is so rule number one is make sure the same thing gets the same name. But the other thing is semantic web is almost or the semantic technology is almost about correct. Everything will only work if you give every object that you define that type. Right? Then a world of opportunities opens up. Apply rules and all kinds of processes to your objects. So anyway, notice if you follow these, then you get to this point, right? If you graph your knowledge graphs, but now you can also link all your graph applications together because you make sure that they will link to the same URIs. Something that sometimes I demo, not going to do today is, for example, we have in our community a round version of geonames. You know that it's a database, 7 million places on Earth. You have the longitude name, population and stuff, right? We have Wikipedia, which is a graph database version of the Wikipedia, so it's a systematic structured version of Wikipedia, expressed in ribbons, right? That's a graph. And we have the census database, also represented as a graph database. If I have these three together, I can just say, what is the median income of the area where Barack was born? And very easily, I go to Wikipedia, find where he was born, right? Get a geonames ID, which is in the drive. I go to geonames in one query. I say, give me all the places within 10 miles of this geonames ID, like 5 URIs for places within 10 miles. I go to the census database that also uses this geonames ID. I find the answer, right? Just 3 databases developed by people in different parts of the world, completely independent, except they care very much about using taxonomies and ontologies and with these standards, right? So they use the same name, and suddenly you can do queries you could never do before. Okay, so so I call this integrated set of knowledge graphs in data fabric. So it kind of came up in 2019, where Gartner said it's going to be one of the top strategic trends in 2022, right? Where you take all the mess you have in your business, like database, BI system, data lake, cloud data storage, all your apps, right? And they have such a hard time working together. Please make it more simple. And so what they said, so they started doing this, and real soon we've got data books like this, about data management at scale, about data meshes and data fabrics. There's books about data meshes, very important data fabrics, enterprise data catalog, right? And according to Gartner, all of that will work way better if you use semantic technology for all your metadata, right? So you can build a data fabric of any technology, any data stack that you want. As long as you make sure that your data catalog, the semantic data catalog, that you kind of have decided that the core objects are important in your company. Describing you're using ontologies, our ontologies. And then you have a taxonomy. So in your companies, do you have a taxonomy team?
Specialty. As a subspecialty.
Okay, so that's yes. In most Fortune 500 companies that we meet, there's a taxonomy team, right? Especially if you want to look at all your unstructured data. If you don't have taxonomy of your enterprise terms, how are you going to even look for anything, right? Anyway, so that's a recommendation. You can build your data fabric on any stack you want, as long as you make sure that you use semantic technology to deal with the so Gartner started talking about it in 2019. We had many meetings with Gartner about the data fabric and knowledge graph that we had built with a big hospital in the New York area. And so in 2022, they came out, 21, they came out with this report where they said, okay, data fabrics are going to be important. This is one of the studies, a case study about entity knowledge graphs empowering AI solutions, in this case in healthcare. And we were very proud to be one of those knowledge graphs that were the examples for data fabric, right? And this example that we built was done with the company, hospital in the Bronx. It's about 3 million patients. stored in this knowledge graphs. We take up all the information that you can imagine about the patient. This graph, and I'll show you in a minute how the graph actually looks like. And the reason why they wanted the knowledge graph is they got very, very tired of building a data mart for every new type of question that came up. Building a data mart is very, very expensive, right? So could we please come up with something that was not not a data mart, but one data sheet for all applications. And we started this already in 2017 with the model with the core patient data. And that was enough to start, say, a machine learning model to predict whether or not the patient was going to need respiratory failure and therefore intubation, right? But then they could use the same data shape also to do sepsis detection, or to find whether lower back pain was just one of the normal things, or maybe cancer that was in the vertebrae, right? Anyway, the whole point is they could use the same data shape in many, many different applications. Right? And the reason why we could do this is that we came up with a modeling, a type of modeling that we call entity event modeling. So you probably know, right, this big trend right now for event-based, temporal representations and event-based representations of data. Most relational database stuff is still that is the current state of the world. People are starting to realize it's probably way better to look at, say, my customer patient or whatever, right, as a series of events, right? Because most of the queries that I find important in life are, okay, what's going to happen next, right? Not describe a situation, but given a series of events, can I explain why this happened? Or can I predict why the next event is going to happen? And believe me, that works better if you have an event representation. So, for health, I'm going to give you this example in healthcare where you have our core entity was the patient, so a whole bunch of patients. Every patient, you have every patient visit, that could be through your local physician or some local, hearing aid clinic, but also a hospital, or anything else, right? Many, many types of visits, and within a visit, there are many sub-events, like the diagnosis, procedure, test, right? Whatever that. And this is basically roughly the data shape that we use in our data. Now, I warned you that it's small, right? This is a picture of our knowledge graph for healthcare. And this is a tool provided with our graph database. It's called the Lego graph. This tool is called Graph. Where on the left-hand side you see the names of the predicates, of the links nodes. Here, it's actually a long list of the types of objects. Now, what you see here is we have one core entity, which is a particular patient. This patient had an encounter. So checking in the hospital. And within that encounter, he had two diagnoses and a procedure. Right? Diagnosis in this case was specified. This is the entity, this is the event graph. Basically, these are all the electronic medical records of the patient that ultimately terminate in these pink boxes, which are ICD-9 or ICD-10 terms. Anyone know what ICD-9, ICD-10 is? Right. Cool. Don't know if the hospital does something with you, there will be an invoice going to the insurance company, right? And a way to communicate between hospitals and insurance companies is through this terminology system called ICD-9 or ICD-10, right? It describes. Anyway, so this is in the event graph, and all these things can be graphed and linked to many, many different knowledge bases. So I don't know if you have heard of UMLS. Made by the NIH, which is about 180 taxonomy systems in healthcare. SNOMED that describes diseases, there's RxNorm that describes medications, there's drug bank, there's no, not all, but about 10 of them. That's not good. All right. Anyway, so there's the entities, there's events, and then there's the knowledge bases. And why is it important? Well, it's a very simple data shape. So we take data from all these different silos, all these rows and columns and complex names, and we simplify the whole shape dramatically. Sure. In the hospital we work with, there's 250 names for start time, right? In a particular table. Like check-in start time. We have only one word for start time. We have only one word for end time. Anyway, point is it's dramatically simplified. The shape is almost always the same. So if I do a question like, give me all the patients that had, say, a particular disease after gallbladder cancers after a particular time, and in SQL, this will be part one of SQL, three parts, sorry, SQL query, where I can show only one page. But in my systems, in our graph database, I can just draw the query as a graph, I push a button, and I get this language that you've never heard. It's called Sparkle. Sparkle, and it will get executed, right? So hard to understand, very easy to understand. First, your queries as if they were a graph itself. The other thing is, I don't want to go too deep, but every fact in the database is something like patient one is named else. Let's say, then there's four elements. The fourth element would be patient one. Right? So patient one is named. Patient one has an event one, event, and the fourth element would be patient one. So I can, in this graph, that's unique to semantic graph databases, bundle a whole bunch of facts together under the same heading. So I can just say, hey, give me all the patients, give me all the information about a single patient. This is done in Python, but in one click, I can literally all the information, literally a million tuples or a million elements, right, in the JSON application development work. Anyway, let me go forward. This we did, I want to talk mostly about healthcare, but just want to make sure you understand this works for many, many different domains. So one of the, we did for the FAA, where we treated the aircraft as patients, right? And all the maintenance records, four different reporting systems, right? As if there were encounters and diseases, right? And so, before repeating, before systems, databases that we got from various places, we kind of cleaned it all up and harmonized it. We kind of put it in this entity event model, and then ultimately we could run machine learning on top. But this is the picture on the show. Same with these patients. For entity, we have events like maintenance record for a master cylinder brake valve, right? Or we have a surface inspection report, something happened in the plane, about the fuselage, right? This is the ICD-10 terms, and then we link it to a huge non-space for the aircraft. Does it make sense? Same shit. Same kind of analytics. One of the cool things that we do in every knowledge graph, we always take the core occurrences and the odds ratios between the most important events. So we always know kind of in the knowledge graph itself the statistical relationships. So I'm not going to talk about it today, given the time. So let's go to the last part. 45 minutes is including questions. Okay. So, as I said in the beginning, right, there is something in this combination of knowledge graphs and LLMs. And so the whole point is LLMs are just amazing in what they can give you, but you can't always trust it. What I really would like is use LLMs, get the data, do the checking on it, and then you put it in the knowledge graph. So that's what we can do. And again, the example is this LLM. Using an LLM for the healthcare knowledge graph, and I'll show you how we create medical notes, and how we use this to predict risk profiles, how we can find causal chains between various phenomena, or search our own unstructured text in the medical database using embeddings. And I'm using embeddings already to find documents. So, and I have this picture of this book here, by the way. Aasman book about the future of artificial intelligence and generative models in healthcare. A lot of the things we do now with our knowledge graph are already described in this book. But anyway, so when we do this LLM thing, one of our use cases is again this medical knowledge graph that we did in the hospital, except we never could show the coolness of our knowledge graph in this hospital because it's got all this patient data, right? So we actually made a copy of the entire structure of what we have in the hospital and replaced the patient data with a system called, synthetic patient data generated by Cynthia. Anyone ever heard of this fantastic system created by MITRE to create patient data? And so we now give this to hospitals. We have a large set of jobs, so any kind of analytics or reporting that you can imagine. And then they can play with it, and if they want to, then we switch out their own data, and they can start going on the knowledge graph in healthcare. So what's in there is by now 360,000 clinical trials you get from the FDA website. Lots of unstructured text. We have several hundred thousand PubMed articles about profits. We have the adverse effects of vaccines, both flu and corona, and we have synthetic data. Give you a data set with 10,000 patients, 100,000, or 10 million patients. In case you want to test the scalability of this. Then at the heart, the thing that ties everything together in knowledge graphs is this thing called UMLS that I just described, right? System of all these different taxonomies, processing and sharing information in hospitals. You have the thesaurus, which is kind of canonical names of things, G codes, billing codes, procedure terminologies, vaccine codes, etc., etc. And almost anything in these databases, structured text, other things like biogrids, all medical terms, all types of this structured text, and also add it to your files of the patients. So we have the patient data, and then you get this graph that I showed before, but I just want to explain the value of a knowledge graph. So we have these medical records. So there's one medical record of Jody who had an encounter where she had acute viral pharyngitis, right? Code, which is linked to UMLS, right? So obviously, acute pharyngitis is described. There's a higher level of acute inflammatory disease, so this is subtype of this, right? Then we have clinical trials, and of course, there's a whole bunch of clinical trials. So these boxes, these are clinical trials. But of course, some of them will also talk about acute pharyngitis. And then we have this PubMed literature. So these are two articles out of PubMed. And again, talk about sore throat, which is ultimately related to this. And then finally, you have the Forrester database, this adverse event database, but again, it's expressed in terms of UMLS. I hope you see the beauty, right? You never could do anything without having taxonomy that ties everything together. And I don't know how people ever would do this in relation to this, but maybe some can. Right. So again, let's talk about some cool stuff we do in the time that we have remaining about what we do with LLMs. Are there any questions so far? Okay. So just for fun, so we have the medical data. So it's a simulated patient data. It's pretty realistic. And if people want very, very realistic data, we also offer a system called Mimic 4, which is actually 40,000 patients that are 100% real, but anonymized data. But anyway, so we have the Cynthia data, and we gave it to a hospital and said, yeah, but Jans, you know, it's so important that we also know how to deal. Can you guys deal with all these medical notes? Right? Not Cynthia, but let's make it, right? So we create medical notes. So we have this, for example, this prompt, right, where we say, we obtain the following data from Cynthia, a program that generates synthetic medical records for randomly generated fictitious patients. I think, why do they stress this so much? Well, for the life of us, we couldn't get anything out of Cynthia, out of LLM about patient data until we said it was synthetic data, and we are students, right? And this is not a real patient. I mean, I had to say it about 4 times, right, before Cynthia would generate medical records, right? And then we have this, right? On the particular date, the fictional providers are the fictional case during a counterclass encounter with organization in the city with this chart, yeah, the following chart. And as a medical student confronting the patient chart in education setting, how would you answer this question and then get the question? Notice it's not a good question. Anyway, then what we would do a query, right, to get the last 5 conditions and the last 5 procedures for this particular patient, last 5 medications that this patient has, and the last 5 observations, and then the 5 last encounters. And then, given this problem, this chart, right now we have the question is, right, to provide clinical notes in a structured style. Can't do this very well. So we checked that people in the medical field is incredibly realistic medical notes. Right? The current state of the patient. So that's one thing, but what I firstly found more fun was to also ask for predictions. So we do a lot of machine learning in our company, right? So we predict whether things will break. The healthcare use case that we described in the Bronx, with all kinds of machine learning models, with neural networks, with some static machine learning together. And that's based on your own data. But ChatGPT has read 36 million .NET articles, right? That's more than you and I ever could read with 1,000 times. Right? Anyway, so there's so much knowledge in there that we also can ask same charts. Okay, give us predict what is going to happen in the next coming year. And so here we get then a diagnosis for hypertension with the evidence and the reasoning. Right? So one of the things that so we can do this with our regular machine learning, right? We can link it up to what ChatGPT. A lot of the projects I hope to do is to take a regular doctor and just have an intuitive look at patient charts, right? That's his impression about the climate. I haven't done it yet. But here's the picture again in graphs. So we have a patient, Jason Bergstrom, that had encounter with, well, notes about viral sinusitis, but also a condition. Anyway. Right? But here, everything you see here is real. Real data, right? And then these boxes are literally also events, right? These are future events, right? With probability attachment. I've done this before in other role-based systems, where we dealt with hypothetical events. It's always fun, right? To have real events and then future events. Look at this as a probability space. So anyway, it's from my perspective, one of the coolest things that I think we work. Taking all these kinds of predictions and see how they match up. Any questions about this? And then the other thing, so here's a query I once did. It's an example of a causal chain from A to B to C, right? Where you this is the prompt. Yeah? You say, okay, I want that from event A, be straight 4 and it's the reference. Then from B to event C, straight 5. C to D, straight 2. Yeah, just to give an example of the structure that I want that. And then use this representation to show causal chain between COVID-19 and colon cancer. Make sure that each of the URLs point to a real medical article or web page that covers the from and the to. Right? And then when I do it, I get this beautiful chain. Here's a causal chain representation between COVID-19 and colon cancer. From COVID-19 to the 2 disruptions in healthcare, strand 4 with the reference. From disruptions in healthcare to delayed colon cancer screening, strand 5 with the reference. From delayed colon cancer screening to increased rate of undetected colon cancer. Right? Makes sense, right? Now, this looks great. But a single link, you've read all about it. Experience it yourself. There's literally not a single link exists. So, what you do then, people who say link chain, we have an link chain, right? Where then for every step in a causal chain, we actually go to the web and say, find articles that prove there's a causal relationship from the COVID-19 pandemic to the So basically, you can use a thing like web chat GPT or use Search API or something like that. Now, you get articles back, right, where each article is checked, and where it's actually the thing you really want. These are all great things. This is how you show them in graph, right? So 19 causes this, causes this, causes this. At this step, for this cost step, right? This cost step, we have a whole bunch of articles. And believe me, each of these articles is correct. It's very powerful. And then there's always multiple ways to link two things together. So basically, we ask ChatGPT the same question that we said, but you cannot have this step across the chain. So now we force ChatGPT to come up with a completely different chain, right? So, and at some point it gets exhausted, but you get a lot of causal chains in your data that you never, well, that you just force ChatGPT to give up, right? Now here, so now, for example, if I have noise bases, right, like the OLS that I talked about before, there's many connections. It's not causal relationships. So, for example, I have here excessive chloride salt intake, all the way down to say essential hypertension. Right? But with my causal extraction technique, right, I get now this picture where this color is this pink, orange. So this is the thing I just showed you. So here we see chloride salt intake is alcohol is also this. Anyway, you get all kinds of connections, but they don't mean that much. Right? Then I start adding ChatGPT in, any LLM for that. OpenAI really does the best so far, right? And I get both the causal chains and the terminology chain. Right? So firstly, I find this just stunning, right? That we get a graph straight out of the LLM. Right? A lot of extra information. We use it for entity recognition. So here we have, for example, an article that already has diseases, drugs, and genes extracted. The bio words, but one of the cool things we started to use ChatGPT for that too. As a medical researcher, analyze the given text and identify the following terms: diseases, genes, enzymes. Again, it's a kind of very interesting way to get your data out of that. And yeah, one of the things that I didn't have time to put the slides in there, but one of the most active things we do right now in the company is to use vector embeddings. So I like the graph tool also. We can already do documents and graphs, of course. But we also now use it to store vectors in the database. So you text, chop it up in smaller pieces that is not GPT, send it to other model, although you can use Llama too if you wanted to get the vector back, right? Now you can do follow-ups, so you can ask questions, and you can literally talk in natural language to your own knowledge graph to get questions about your own unstructured. That would be a whole other story. So, this month and next month we'll have a new version of Graph, and you can actually play with it yourself if you want to. Actually, I also have a hosted version of that where we embedded a lot of ChatGPT capabilities or LLM capabilities directly into our query language called Sparkle. For example, we can say, I want to create a table of all US states, capital, population, area, the capital, population, the area, admission, when it was US, governor, and the celebrity, right? Just in this language, we have called Sparkle, let's say select state capital, pop area, major government celebrity, where you started, okay. Write the capital city, write 10 randomly selected US states, adjacent area of streams, and go. In this, you can't write Sparkle, but this is what we call a magic predicate, and it will create all the states. So we did a lot of work to ask questions of an LLA to look at the results, but as part of this to adjacent structures, right? Because once you do that, then you can embed it in the query language. You can treat almost like the LLM is another database that you can query, right? And this is a whole series of queries that once you've played it, that's I said before, oh, you have a whole bunch of examples. Just playing with this. And so my conclusion is that I think that knowledge graphs and data fabrics can be your trusted source of truth in this fantastic but also fantasy world of LLMs, right? Store the output of LLMs in your knowledge graphs. You can check once it's in there, you can check the output of LLMs with other mean. Okay, thank you.
So the example node alone fusion application looks like the schema is well defined. Question will be how hard is it going to update the schema? For example, you're going to add a field, remove a field, rename a field. Is it
No, so we make this assumption that almost everything can be described as an event. Apart from what you need, most demographic information is kind of static. The rest is events. And the events are always the same shape, right? You have a start time and an end time, possibly end time, maybe a location, always a type. And so these event structures hard to change, right? I mean, the data relation database changes all the time. All we have to do is to write a mapping of that to our simplistic model. And people always are afraid that they have to take all the data. See people just 4 or 5 types of events that they extract. It's kind of like a non-monotonic. You can just keep that again. So you can do more. Don't hardly to delete anything or change the events itself. I didn't read the question.
So just to be clear, everything we saw here was from Allegro Graph?
Yeah.
And okay, and so how much of the naming and developing the ontologies and taxonomies is that just supplied from subject matter experts or a governing body for these different business domains, or is
NIH spent an enormous amount of money on creating and organizing all these taxonomies in healthcare, right? That's so that it's a regular process. For files, it's a regular process to create those. IRIX norm for medications. I mean, all of these things are structured, and basically, we take all of the unless we actually started defining this as a service to several customers. They want to go through the trouble to keep all these things up to date. Service, but believe me, you can do it all yourself. It's a lot of work. Do it all yourself, and we curate it. It's in UMLS. Yeah, in taxonomy is always a good concept. It's a more broader concept. And at some point we found out that there were circles.
synonym rings.
Synonym rings. So basically what we do now, we discover synonyms, and then basically for every ring, we ask ChatGPT, what is that? Is A more specific than B, or always be more specific. And we've automated that. So literally, we can use LLM to curate. We still get a list of the it's not about several thousand rings that we have to look at. That's awesome. Curate.
I guess what I was getting at was if you're working in an industry that it isn't so well curated. Like I just finished a music industry product, and there's no standardization at all in that industry. You're just on your own to put that together, and then you could use the Lego graph to take it. Okay, got it. Thanks.
Can I?
I think she's.
Sure.
Thank you. I think the question or the example around healthcare is fascinating because supposedly we have a common goal about trying to ultimately be able to provide some kind of automatic diagnosis of disease and maybe manage care better, etc. So I'm just curious when your approach is definitely based on knowledge graph first, which putting more guidance and logic behind all the reasoning and analytics, while adding LIM on top of it. While on the other hand, OpenAI is starting all this collaboration with healthcare data, and adding to the fact that you mentioned the healthcare data itself is kind of having certain standards and structure, etc. So I'm just wondering, your approach versus their approach, just putting LLM being trained on healthcare data, and supposedly we're having the same goal of ultimately diagnose automatically, etc. Can you maybe comment on the pros and cons versus your approach versus theirs? I mean, of course, we don't really know that much details about OpenAI and healthcare yet, but I'm just curious.
Well, I think our approach is probably the same, except they've got $10 billion from Microsoft. So they can do a really good job, I think. There. Based off that book that they showed, right? It's a fantastic book that describes basically the question that you just had, right? How do we deal with all the government data? Oh, by the way, so one of the things they're going to do, I can pay for, wouldn't even have the data for, but right? So you know how recurrent neural networks work, right? Series of defense, almost like it's a language, it's a sentence of words, right? The word embeddings over these words, and you put that as an input into other neural networks. They're going to do that for healthcare data too. So they're going to take endless amounts of event streams for patients where they know supervised they're doing it, right? So here from this event, this happened for this patient. They're going to use the same processes that they use for natural language of chains of patient data, and we've actually done this already for Synthia, for Limit, like the same approach, but they're going to do it on probably 250 million patients, right? It's amazing what's going to get out of that. That book gives a lot of answers about it. We've done it on a small scale with Synthia data. Anyway. I'm never afraid of this because I think doctors will use it as a heuristic thing, right? As long as you don't treat it as 100% true, right? But help the doctor, because in that book also describes that for certain combinations of symptoms, right? No doctor would ever think of a particular disease, right? But it would do. This context sensitive, I did 1.5 years ago, Lyme disease in California. Now, my doctor in the whole clinic had seen Lyme disease. After 3 months, he finds out, oh my God, get yourself tested for Lyme disease. I had Lyme disease. I got it in time. If my son lives in New Jersey, right? You go to the doctor, the first thing he thinks is, well, maybe it's Lyme disease. There it's, I mean, everyone gets it. It's different. Can you imagine an LLM looking at where do I look? Right? With symptoms, right? But the LLM would still come up with Lyme disease, right?
one more question and then take questions offline.
Yes, hi. So if you have a generic organization or a company, and then you have most of your data in the data warehouse, and you have started out with the knowledge graph. So let's say you have 10% of your information in the knowledge graph so far. What would be your recommendation to start doing analytics with the knowledge graph, but you still have the rest of the data?
So we worked with a very, very big bank. They said any analytic they want to do 10% of their data is not good enough. 10%. It's so much metadata, control data that you don't need. Bank customer, it's about every transaction that you had. So much control information looking at your data to make sure that the provenance. Like in health, in a hospital, we work with 75% of all data in the knowledge graph. It's provenance data, right? Every interaction, every diagnosis, where did it come from? What was even the Oracle IDs were in the knowledge graph? It was a back part, so that they could always check. Even there, I know 10% of the data. There is databases. So you have Epic in a big hospital, right? So much control information that you don't need for your analytics. And then, of course, there's things like virtual databases, like virtual software nowadays. We can lift Sparkle queries against relational data in databases. Very needed.
So more federated than
It's more federated, yeah.
than importing or combining.
But again, I never recommend people do everything with friction because there's immense value in this reduction step that I do, right? All these rows, columns with all these horrible names, right? So the incredibly simple effects. Circumvent code this one big timescale database, right? Other stuff. Except now you can't do all the cross connections with the taxonomies or speak by the same doctor before you have like take a while. This makes sense. All right.
Thank you.